Hey, good morning, everybody. We're in 8.3 here at AP Pre-Calc here, and you're with Mr. Ainsworth. Good to see you guys. We are going to get into a little mind map on roses. And so remember, mind maps is all about like concentrating your focus on one key concept. And we're talking about polar functions and roses in specific here, and we're going to get into it. And when you do a mind map here, what you want to do is develop in such a way so that you get all the different variations. Okay, so that's why we have two different functions for cosine, one with a being positive 3 and one with a being negative 2. And then the first one here deals with n equals 2 where it's even. All right, and the second one, n equals 3 where it's odd. And then, of course, we're going to deal with the sine cases too. All right, so you want to develop a mind map where you have a variety of different possibilities to explore and study so you can really understand how the polar function works with roses. And again, the whole idea is to do this entirely without technology. No TI-84, no Desmos. That was used only in the beginning lessons, right? And then you want to practice in such a way so that you can actually graph these functions, determine all the characteristics without using a graphing calculator, whether it's a TI-84 or Desmos, it doesn't matter. All right, so let's zoom out on here. Let's take a look at our first function here, r equals 3 cosine of 2 theta. All right, and take a look at some observations. So first of all, okay, so what we want to do is take a look at our first function. R is equal to a times cosine of n theta, and make some observations. First observation is that a equals 3. That's pretty obvious. So a equals 3, and that tells me that gives me information on the petal length. Okay. And that right there is determined from the lesson. Okay, that's just something you have to know. And how do you get that? Well, guess what? We're going to do what we always do in like in all my videos here. We're going to take a look at, you know, substituting some values. Okay, so let's let theta equals 0 radians or 0 degrees, doesn't matter. And let's take a look at the radius. Okay, so r is equal to 3 times cosine of, guess what, 2 times 0. Well, 2 times 0 is 0, okay, and cosine of 0 is 1, and 3 times 1 is 3, so that tells me that 3 comma 0 is on the graph, okay, it's on the function, it's on this rose, and that gives me the tip of the petal, okay, so this is the tip of the petal here. I know a equals 3 is the petal length, and now I know where it starts. And the fact that we're dealing with cosine here, cosine function always starts, or the first petal starts, on the polar axis. It happens every single time. So on the polar axis, it may be on the right side, it may be on the left side, and that depends on a value, right? And this time a is positive, so we start on the right side. So polar axis. Now, remembering all this stuff is kind of hard to remember, so do what I just did earlier. Substitute 0 in the function, figure out the radius, and then you can plot. And then, of course, the petal length is at 3, and so now we know. The other thing you need to know about roses is that how many petals there are. So here comes the n value. So when n is 2, all right, that's an even number. So I'm going to write down even, and whenever n is even, that tells you you have double the amount of petals. So we have 2 times 2, or 2n petals, which is 4 petals. And the last thing you need to know is how many degrees apart they are. And all petals are divided equally around, or evenly spaced around the circle, which means that if you take 360 degrees divided by the number of petals, which in this case is 4, so you have 360 divided by 4, that tells you there are 90 degrees apart. Okay, so once you find the position of the first one, which we now know, at the polar axis right here, you space them 90 degrees apart. So I'm going to go up, and I'm going to go left 3 units, and then down 3 units, so they're 90 degrees apart, and then sketch your function. Okay, so let's do it. All right, so here's the first petal, second petal, and you make sure that you do not overlap the petals. Okay, there you go. And the petal length is at 4. They're 90 degrees apart, so from here to here is 90 degrees all the way around. Now, obviously, the axes are 90 degrees apart, so the petals are 90 degrees apart, because these petals are on the axis. Oh, and that reminds me. So it's cosine. Okay, so we got some symmetry around the polar axis. In this case, it's got symmetry around the polar axis. It's got symmetry around the y-axis, and it's also got symmetry around the 45-degree line. So it's got a lot of symmetry on this one. Okay, and that's your first one. Okay, where we deal with where A is positive, but guess what? A can be negative. So here we go. So when A is negative, what happens? Okay, so here A is -2, and what am I trying to say here? And then what you want to do is take the absolute value of A actually, and the absolute value of -2 is 2, and that gives you your petal length. Okay, when in doubt, you substitute a value in. So here we go again, like I did before. I'm going to substitute in 0. And what do I get for the radius? Well, watch this. We get r is equal to -2 times the cosine of 2 times 0. And if you remember, which you do, okay, cosine of 0 is 1 times -2 is -2. So -2 common zeros on the graph, which tells me that the first petal doesn't start on the right side on the polar axis as the first one here. Okay, it starts on the left side of the polar axis. Okay, so at -2 comma 0, so I'm going to plot over here at -2. All right, but how many petals do we have? So we got to figure that out too. So here n is 3, and guess what? That's an odd number, and that tells me we have 3 petals. Okay, when it's odd, the number of petals is equal to n. So we have 3 petals. How far apart are they? So we take 360 divided by 3, and you get 120 degrees apart. Okay, all that stuff is important to know. Okay, so now I know where my first petal is. So I'm going to graph it here. Okay, there we go. There's my first petal. Now they're 120 degrees apart. So what I want to do is I want to go 90 plus 30. 90 plus 30 is 120. So here there's 30 degrees. I'm approximating obviously. And then down here is approximately 30 degrees. 90 and 30 is 120. I'm talking about this angle here, and I'm also talking about this angle here. So you figure out where 120 degrees is because they're 120 degrees apart, and then you plot the function. So 2 units up, maybe right around here. 2 units over here, right about there maybe. And then you graph your petals. Trying to get the right thickness here, so sorry. There we go. And then you can verify this with Desmos, of course. Okay, and I always do this in my videos too, so you just whip out Desmos here. And then I'm using the one that we had in the activity in class. So I've got to figure out I got to change my sliders here. So A is -2. Okay, so change it to -2. N is 3. There we go. And let me see. Let me see. I don't have the right function graphed. You got to put on the right function. So I click on r is equal to a cosine of n theta, change a slider to -2, n is equal to 3, and there you go. And guess what? There's your graph right there. There we go. So now you can see it. All right, so you can verify everything with Desmos. Just keep that in mind. Okay, so let's get back into it here. Now we're dealing with sine. So let's switch to sine and see how things change. Okay, so once again, here we have r is equal to a times the sine of n theta. So I know a is 4 and n is 2. So here a is 4. It's positive. All right, so we want to analyze this first. It's positive 4, so that gives me my petal length. So now I know the petals are length 4. I know 2 theta. Well, actually, let me verify that. So this is sine. So sine's a little bit different. You just don't substitute in 0 because it's different for sine. We know for sine, here we know that n theta is equal to 90 degrees all the time for the sine function only. And so now we have 2 theta equals 90. And if you divide by 2, you get 45. So now this is for the first petal. Okay, this is first petal fact. So let me write that down too. First petal. So what I'm going to do is go ahead and draw the 45-degree line here. Also on the other side here too, you'll see Y here in just a minute. Okay, there we go. So this is at 45 degrees, so 45, 135. You guys should know this from the unit circle. Okay, we've done plenty of masteries on that. And then I want to verify something. Watch this. When theta equals 45, look what happens. R is equal to 4 times the sine of 2 times 45. Now, 2 times 45 is 90. Sine of 90 is 1, right? And 4 times 1 is 4. So already I know that 4 comma 45 degrees is on the graph. So I'm going to go up 4 units and plot a point. Now, on the horizontal, 4 units is about here, so I'm going to have to approximate. Because remember, we're dealing with a circle, right? Okay, so maybe 4 is about here. So here's my first petal. Okay? And then, what's my next one? Okay? And what's my next one? And they all length 4. There we go, all length 4. So petals have the same length and they're evenly distributed around the unit circle. So again, here on this one here, the angle between petals, let me see, 360 divided by 4, 90 degrees. This is the angle between petals. Angle between petals. You always got to figure this out for roses. And notice that there's 90 degrees in here because 45 plus 45 is usually 90. Okay, so the angle between petals is 90 degrees. Okay, all the way around the unit circle. Okay, or any circle actually, because it's just a circle. All right, there you go. I'm going a little bit fast only because I'm in a video here, and so if I was doing this like as a student and I was turning this in, I would do a little bit better job and slow down. Okay, but you got the idea. Okay, now this one's a little tricky, so you got to be careful here. So here r equals negative 6 sine theta, where a is negative 6. So here a is negative 6. And if you take the absolute value of a, which means you take the absolute value of 6, you get 6, and there's your petal length. But it doesn't, you got to be careful where it starts. So let's dig a little deeper here. So we got 3 theta is equal to 90 degrees. And again, this is only for sine, all right, not for cosine. Cosine, if you go back here in the first 2 examples, that's the first petal starts on the polar axis. Not true for sine. For sine, it starts wherever n theta equals 90, and in this case, it's 30 degrees, but a is negative, so you got to be a little careful. Okay, so watch this. Because I'm going to substitute in 30 degrees. Watch what happens. Okay, so r is equal to negative 6 times the sine of 30 degrees. Or excuse me, 3 times 30 degrees. Let me change that. So 3 times 30 degrees, which is 90 degrees, and the sine of 90 degrees is 1 times negative 6. That means that r is negative 6, which means that negative 6 comma 30 degrees is on the graph. So you have to plot this. Okay, so here we go. I'm going to graph 30-degree lines. So this comes from your knowledge of the unit circle here. I'm estimating here. So this is 30 degrees, and so is this. And then I'm going to graph 6 comma 30 and then reflect it across the pole to get to negative 6 comma 30. So 6 comma 30 would be, let me see, 2, 4, 6. So it's probably right around here. This is 6 comma 30 degrees, but negative 6 comma 30 degrees is on the other side, the same distance away, because it's a reflection across the pole. So 2, 4, 6, probably right around here. That's, okay, where, oh, hang on. Come on, Aynesworth. Let me put it back here. So this is where that point is, negative 6 comma 30 is. So now we have the first petal. So I'm going to just sketch it here. Okay, there's my first petal. It's length 6 and is at 30 degrees in quadrant 3, or at actually 210 degrees in quadrant 3. And where's the next one? So they're 120 degrees apart, right? Well, how do you know that? Well, I just kind of blurted that out. So 360 divided by 3 is 120 degrees apart. So I got to count 120 degrees from where I'm at. And so if I count 120 degrees this way, I'm on the y-axis. So I'm going to go up 6 units. 2, 4, 6, and plot a point. I'm at 6. So now I know my next pedal. There's my next pedal. And now I need another one that's 120 degrees apart. So I got to go 90 and 30 more. All right, so now I'm down here. So this is 30 degrees. 90 and 30 is 120. So this is 120 degrees right here. And now what I do is I plot this one. I go 6 units down here. Again, they're all the same length, right? And I graph my next one there. And then what you do is you bring in Desmos, your best friend, and you confirm your conjecture. And because this one was difficult, I'm going to show you in Desmos what this looks like. Okay, so on this point here, I need to change a to -6. So here we go. Here's -6. Okay, and then I've got to change it to sine because we're not dealing with cosine, we're dealing with sine. And lo and behold, look at that. It's the same graph, guys. Ho-ho! Ho-ho! Now you notice that the pedal, the one in quadrant 3 is at 7/6 pi, right? That's 210 degrees. 180 plus 30 is 210, which is equivalent to 7/6 pi. And the one in quadrant 4, okay, that's at -30 degrees, and that's -pi6 or 11 pi 6 coterminal. So, and the third one on the y-axis, that's pretty darn obvious. Okay, so there you go. There's a full-on review in the form of a mind map of roses. And what you guys need to do is learn how to study effectively, like develop a mind map on a particular concept and be focused in on that one particular concept, like roses, for example, polar functions with roses, and then go through all variations and everything that you can think of in one particular concept. And that, my friends, is how you study effectively. So you do this with everything. You do it for the circles, the roses, the limosons, everything. In fact, tonight's assignment, all right, if you're with me today in class, is do a mind map on limosons, okay? And there's 4 different types. So you need 4 different functions for limosons. Develop the mind map, check it with Desmos to make sure you're right, like I just illustrated, and you're good to go. And make sure you know everything about them. And make sure also that you can do this without technology, without the T84 and without Desmos. All right, this is Aynesworth. Hopefully that helped you out. Study effectively, and I'll see you in my next video or lesson, and hopefully in class. Take care.